Dear students, welcome to SRK online classes. In the last video, we have discussed about ozonolysis. What is ozonolysis? And I have done two different types of questions. Question number one, starting compound is given, you have to identify the final products. Question two, retro-ozonolysis means where products are given, you are supposed to identify the corresponding hydrocarbon, that is alkene or alkyne. Already we have discussed ozonolysis is useful to find out the position of multiple bonds in a given organic compound and also useful for the identification of structure of unknown organic molecules. The application part we have not discussed. And second thing, types of ozonolysis and types of reagents which are used in the ozonolysis we have not discussed. Today we will concentrate application part of ozonolysis as well as uses of ozonolysis we will discuss and reagents used. So first I'll take a common example here. Propene. This is the structural formula of propene. Propene on ozonolysis. In the previous test, what we have used is O3 and zinc and H2O. This is said to be reductive ozonolysis. We have already discussed about the mechanism part. Now I am giving the shortcut method to write the final products if the starting compound is given. Propene. If you want to write the products, wherever double bond is there, cleave the double bond or remove the double bond, write oxygens on either side. Therefore, products are CH3, C double bond OH, one product, plus formaldehyde. Here, we have cleaved the bond. Oxygen, one oxygen I have represented here, another oxygen is represented here. First part is aldehyde, second part is formaldehyde. Already I have given. Now, here, zinc reacts with H2O2 because H2O takes one oxygen from ozone, that will be converted to H2O2 and which will be converted into zinc oxide plus H2O. Therefore, it is called as reductive ozonolysis. Now, if zinc is not present, ozone and H2O if it is taken, that is called as oxidative ozonolysis. In oxidative ozonolysis, I am writing addition of ozone. First step, we will write in this manner. Wherever double bond is there, write ozone in the form of cyclic structure. In the second step, hydrolysis, H2O. So this cleavage will be like this and oxygen will combine with this one, that will be converted to hydrogen peroxide. First part is CHO, C double bond OH. Second part is HCO double bond OH. And this H2O combined with oxygen, that is converted to what? Hydrogen peroxide. We know that hydrogen peroxide acts as an oxidizing agent which oxidizes here H2O2 oxidizes acetaldehyde into what? Acetic acid plus formaldehyde will be converted into what? Formic acid. Formic acid further undergoes oxidation with hydrogen peroxide gives carbon dioxide plus water. So, this is said to be oxidative ozonolysis. First one is reductive ozonolysis, second one is oxidative ozonolysis. Right? So, last class we have discussed about the first part, not the second one. Today I have given oxidative ozonolysis. Here, difference between these two is zinc, if it is present, that reduces the hydrogen peroxide to zinc oxide plus H2O, that is called as reductive ozonolysis. But whereas if zinc is not present, that will be called as oxidative ozonolysis, where byproduct is hydrogen peroxide which acts as an oxidizing agent that oxidizes aldehydes into corresponding carboxylic acid. Exceptionally, wherever formic acid is formed, it undergoes further oxidation to produce carbon dioxide water. Not other acids, only formic acid. That is called as oxidative ozonolysis. Now, let us take the different examples, different reagents which are used for ozonolysis. I am taking the second example. Here I am taking second example. CH3, CH3, double bond, CH, CH3. This is 2-methyl 2-butene. These are the different reagents. I am writing first one ozone, second one dimethyl sulfide in presence of water. Second one oxidative ozonolysis, ozone, and second one is H2O. Now we have tried the products here. So dimethyl sulfide function as just like zinc. Zinc and H2O, whatever the products are there, instead of zinc I have taken methyl sulfide. Here the products are already I have given. Wherever double bond is there, just leave the double bond, write both the sides oxygens. These are the products. So first product will be what? CH3, C double bond O, CH3 is nothing but what? Acetone. Second part is what? C double bond O H and CH3 is nothing but what? Acetaldehyde. Plus here dimethyl sulfoxide. Dimethyl sulfide will be converted to what? Dimethyl sulfoxide, abbreviated as DMSO, a protic polar solvent, right? DMSO plus as usual that H2O will be there. Now this is called as reductive ozonolysis. Now if you take H2O, oxidative ozonolysis, first step will be the products will be as it is, acetone plus, and aldehyde is formed, C double bond OH and CH3. H2O2 being a mild oxidizing agent, it cannot oxidize ketone. Only aldehyde will be oxidized by hydrogen peroxide. That gives acetic acid, and this will be as it is as acetone. This is called as oxidative ozonolysis. What I have given is here, instead of taking zinc and H2O, dimethyl sulfide I have given. So this is another reagent which is used in ozonolysis process. Sometimes you can also use third reagent like ozone will be as it is. Second one is lithium aluminium hydride in presence of water. Look at here. The third reagent I have used. First ozone, zinc and water, ozone and water, ozone and lithium aluminium hydride. Now we'll see what are the products formed. First step will be as it is. You are getting here acetone. Second molecule will be acetaldehyde. This part will be same. Now lithium aluminium hydride being a strong reducing agent that reduces ketones into corresponding alcohols that produces secondary alcohol. Ketones produces secondary alcohols, whereas aldehydes are converted into primary alcohols. Here you will get CH3, CH2OH. This is the third reagent I have used. So these are the different reagents used for ozonolysis. So depending upon the reagent, products are formed. Right? Now we'll continue for the cyclic structures. Ozonolysis in cyclic structures. I'll take few important examples for cyclic structure. First I am taking styrene, vinyl benzene I am taking. This is the structural formula of vinyl benzene. CH double bond CH2. This is called as vinyl benzene. Is also called as styrene. Suppose if I take ozone, only one equivalent. Second one, zinc and water. Write the product. Second one I am taking cyclopropene attached with another cyclopropene. Here also I am taking ozone, one equivalent, followed by hydrolysis, zinc and H2O. Write the products. Third one I am taking ozonolysis, O3 plus zinc and H2O. What are the products found for these three? You try. Take 1 or 2 minutes time. An important thing is what? There only one equivalent. 1 mole of ozone is possible. Or when we are using only 1 mole. Means selective reductive ozonolysis. Which double bond is reduced that you have to identify. Look at the first one. Originally it requires 4 moles of ozone. 3 double bonds are inside the benzene and 1 is outside of benzene. These 3 are in aromatization process. They are inert. It is very difficult to subject the ozonolysis part of benzene. And left out is this one. Out of these 4, easiest one is what? Outside the bond. Therefore, that produces benzaldehyde plus formaldehyde. That is the product. I'll write once again. One is benzaldehyde and second compound is what? Formaldehyde. That is the product form. Only outside double bond will be easily undergoes ozonolysis bond. Look at the next one. Here, 3 double bonds are there. Which double bond selectively undergoes ozonolysis very easily? Here, 1 double bond is there. This is another one. These 2 are difficult and this is very easy. Why? Because whatever the products which are formed will be aromatic compounds. Stabilization of that molecule is more. So therefore, instead of opening the ring, only this double bond undergoes ozonolysis that produces 2 molecules of cyclopropenone compounds. Why this compound is formed? Because these 2 electrons are shifted here and that forms a resonance structure like here O minus and positive charge. So cyclopropenyl cation is what? Aromatic. That's why the compound is stable. These are selective ozonolysis which depends upon the product stability. So if I cleave here, that is unstable compound. Therefore, selective ozonolysis is taking place. In similar manner, here also same thing. What you will get here? That inside double bond will be as it is, and here you will get C double bond O plus carbon is there, that will be converted to formaldehyde. Look at carefully. Both are stable compounds. Just like the previous one, it is shifted here. Negative charge and positive charge. This is aromatic. Therefore, this is a selective reductive ozonolysis of some cyclic compounds I have given. We'll take some more examples of ozonolysis for cyclic compounds. Now I am taking one of the important example. Benzene. This is the structure of benzene, which is having three double bonds. Ozonolysis. First step is ozone, second one is zinc and H2O. Three double bonds are there. This is one double bond cleavage will be taking place. This is another double bond and this is another double bond. Now each part, you take anything, this is first carbon, second carbon, third, fourth, fifth, sixth. All three are identical. That is nothing but H, C double bond O, C double bond OH. Three molecules are formed. This is called as glyoxal plus zinc oxide and H2O. Benzene on ozonolysis gives 3 moles of glyoxal. One of the important compound. Same manner, already I have given. Ozonolysis is used for the identification of structure of unknown compounds, as well as it is also used to confirm two resonance structures of benzene. Benzene is having two Kekulé resonance structures. Presence of those two Kekulé structure can be proved on the basis of ozonolysis product. I am taking one simple example here. I am taking dimethyl benzene is nothing but xylene. This is the structural formula of xylene. CH3. Dimethyl benzene is called as xylene. If xylene is having only this structure, what are the ozonolysis products? I am writing the ozonolysis. Addition of ozone followed by hydrolysis in presence of zinc and H2O. So what is the type of cleavage? Now look at here. Wherever double bond is there, cleave. Second double bond here. Third double bond here. Now I am writing, this is the first one, part 1. Part 1 is CH3, CHO, CH2. Therefore, you will get part 1, I am going to get CH3, C double bond O, C double bond OH, methyl diazole. First carbon, second carbon, and this is third carbon. This part I have taken CH3, C double bond O, C double bond OH. Same manner I am taking the second part. This is second part. In second part also same. 1, 2, 3 carbons. That also methyl diazole. This is third part. In third part, what you are getting here? H, C double bond O, C double bond O, H. This is called as glyoxal. Now, if orthoxylene structure if it is this one, you will get only 2 products. But originally, orthoxylene is subjected to the ozonolysis, produces 3 products in the ratio of 3:2:1. That cannot be explained on the basis of this structural formula. Here, 2 methyl groups are attached with what? Double bond. What is the other resonance structure? I can write the same compound in a different way. Now I am writing this way. Look at carefully. Double bond, double bond, double bond, and methyl groups. What is the difference between these two? Both are orthoxylenes only. But here, methyl groups are attached with a double bond. Here methyl groups are attached with what? Single bond. Now what are the products? If orthoxylene is having this structure, products I am writing. Cleavage will be like this. Second cleavage, this is third one. This is the first product. This is second product. This is third product. 1, 2, 3. I'll write separately all the three products here. Product 1, CH3, C double bond O, C double bond O, CH3. This is first carbon, second carbon, third carbon, fourth carbon. Dimethyl dioxide. Part 2 I am taking, only two carbons are there. H, C double bond O, C double bond O, H, glyoxal. Third one is also same. Suppose if the structural formula of orthoxylene is the second one, once again you are getting only two products. But what are the final products of ozonolysis of orthoxylene? It produces three types. What are the three types? Dimethyl glyoxal, methyl glyoxal, and glyoxal. That clearly indicates orthoxylene is having a two resonance structure. If it is one resonance structure, only one product is formed. Therefore, ozonolysis of this one, ozone and zinc and water produces what? Three products. That is dimethyl glyoxal is 1 mole, methyl glyoxal 2 moles, and 3 moles of glyoxal is formed. Yes. Now look at carefully. Here, methyl glyoxal. How many methyl glyoxals are formed? 2 methyl glyoxals are formed. And 1 glyoxal. Here, 2 glyoxal. Total 3. This is 2. This is 1. Therefore, ozonolysis is used to find out the resonance structures of orthoxylene. That is one of the important application part. Similarly, ozonolysis is used to find out the structures of unknown compound. We'll take another example. I'll work out another example. Now let us take molecular formula of unknown compound is C4H8. Molecular formula of unknown compound is C4H8, which on ozonolysis produces addition of ozone plus zinc and H2, produces two products X and Y. Y will undergoes Cannizzaro reaction and X gives iodoform reaction. What are X and Y? X and Y. Now, this is the question. From which we can what? Identify the structure of the molecule. C4H8 indicates what? It is not a saturated compound. It is not a saturated open chain compound. If it is open chain compound, number of hydrogens are what? Cn, H2n plus 2 alkane. Number of hydrogen must be 10. Here 10 hydrogens are not there. Therefore, it is not a saturated open chain compound. Second one, what is the alternative? It can be cyclic saturated compound. So, cyclic saturated compound means what? I am writing here cyclobutane. Molecular formula, this compound C4H2, this is identical. But this does not undergo ozonolysis because as there is no double bond or a triple bond, does not undergo hydrolysis. Therefore, the structure of C4H8 is not correct. It is not a cyclic compound. It should be what? Open chain compound with unsaturation. How many hydrogens are there here? 2 hydrogens are less, means 1 double bond. So, number of equivalent double bonds is equal to what? 1. So, therefore, with 1 double bond, how many possibilities are there? Let us see. I am writing the first possibility. CH3, CH2, CH, double bond CH2, alkene. Yes, 4 carbons are there. Second one, 8 hydrogens are there, one double bond. This undergoes ozonolysis. Yes. And it forms X and Y. What are X and Y? This part is formaldehyde. Yes, very good. This undergoes what? Kenneth-Lewis reaction. Done. What about this one? This is Y. X is equal to what? Propanaldehyde. Look at here. Propanaldehyde. But it does not undergoes iodoform reaction. Alpha methyl group is a basic requirement for iodoform reaction. There is no alpha methyl. Therefore, iodoform reaction is not possible. Therefore, even second structure is also wrong. Now the third possibility I am writing CH3, CH, double bond CH and CH3. If this is correct, it undergoes ozonolysis. Because what? It is having a double bond. Next one what? On ozonolysis produces two products, but both are identical. But here it should be different molecule. One is Kenneth-Lewis. What are the products found here? CH3, C double bond OH. Two molecules. It undergoes hydroform reaction, but Kenneth-Lewis reaction is not possible. Therefore, this is also wrong. Second structure is also wrong. Then I write another structure here. CH3, CH3, double bond CH2. Look at here. Now this on ozonolysis produces O3 and zinc and H2O. Look at carefully here. What you get? CH3, C double bond O, CH3 plus HC double bond OH. This undergoes Kenneth-Lewis reaction. What is the condition for Kenneth-Lewis reaction? Carbonyl compound which are not having alpha hydrogen atom in presence of alkali undergoes disproportionation to give alcohol and salt of carboxylic acid. Yes, there is no alpha hydrogen atom, therefore it undergoes Kenneth-Lewis reaction. Look at other side. Here, this is the functional group. Alpha methyl groups are there. Therefore, it gives what? Iodoform. When it is treated with iodine and alkali, gives yellow crystalline compound known as iodoform. Therefore, the structural formula of that compound must be isobutene. What is the conclusion here? Ozonolysis is used to find out the structures of unknown compound. Right? I'll work out one more, the last example for ozonolysis part. Now let us take alkynes. Alkynes also undergoes what? Ozonolysis. I take two different examples here. This is a one example, CH3, C triple bond H. One is ozone, zinc and H2O. Here also, only double bond. These two bonds will be clean. Therefore, the products formed will be CH3, C double bond O, C double bond OH. This is called as methyl glyoxal. Plus byproduct will be zinc oxide and H2O. This is reductive ozonolysis. And same thing, if it is carried out, ozone plus H2O, oxidative ozonolysis, gives what? First, it gives the same product as given in the previous case, and this undergoes oxidative ozonolysis. Cleavage of bond is taking place. That will be converted into acetic acid, and other part will be converted to formic acid. We know that formic acid further undergoes oxidation to give what? Carbon dioxide and water. This is called as oxidative ozonolysis. This is what? Reductive ozonolysis. The same manner, I am taking another example. CH3 2-butyne. What is the ozonolysis here? Ozone plus zinc and H2O. What is the product form? Remove the double bond. Zinc, C double bond O, C double bond O, and this is called as dimethyl glyoxal. I'll write one or two questions which are repeatedly given. It's the last question. This is about alkynes ozonolysis. Retro-ozonolysis means where product is given, you have to identify starting compound. X on ozonolysis produces this compound. What is X? You just try. Only one product I have given with same number of carbons you have to identify. Starting compound contains same number of carbons, but only one product is formed. Whenever it forms same number of carbons with one product, it is understood it must be a cyclic compound. Therefore, here I am writing 1, 2, 3, 4, 5 and 6 carbons. Therefore, this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon, this is sixth carbon. Remove these two oxygens. That gives what? 6 carbons. And double bond will be here. That X is nothing but what? Cyclohexene. So that's about ozonolysis and its applications. If you like this video, kindly promote it. Thank you.